Hello, welcome. So in this video we are going to talk about an inertia measurement unit IMU based sensor. So as you can see that I have this breakout board which is termed as 9 degree of freedom 9DOF razor and IMU. IMU stands for inertia measurement unit. So for example, we need to understand what is an inertia sensor, and based on that we will understand what is then inertia measurement unit. So inertia sensor, so first thing is that what is an inertia? So inertia is a property from the physics, Newton's first law, which states that if the body is at rest or it is moving at a constant speed or a constant velocity, it will remain in that state unless acted upon by an external force. So unless some external force interferes with the body at the rest or a body moving at a constant velocity, it will hold that initial state. That's your Newton's first law of motion, which is also called as law of inertia. So based upon this physics property or physics principle, there have been sensors that are called as inertia sensor, which are used to detect whether that external force has occurred to alter the position of the body which is at rest or the body which is moving at a constant velocity. So in the previous video we have seen a sensor called as accelerometer that was used to detect the change in velocity or a change in position, which is velocity, and change in velocity is an acceleration, so we called it an acceleration. So that sensor, we saw how it is used to detect a change in velocity in all three axes, that is axis x, y and z. So please refer to that video. And now in this module I am going to introduce to you another type of sensor which is also called as inertia sensor, is called as gyroscope or simply a gyro. So gyro sensor, GYRO. So accelerometer, as said, is used to detect a change in linear velocity. On the other hand, gyro sensor is used to detect the change in angular velocity. For example, your fan in your house is rotating. So there is a rotation of an object or a physical quantity. So that angular velocity, change in that angular velocity can be sensed by a gyroscope. It is also called as angular rate sensor or angular velocity sensor or tilt sensor. So for example, you hold an object in your hand, let's say the TV remote, and then you tilt it in either direction, in either axis x, y or z. So this sensor will convert that rotation into proportional electrical output, and output divided by input would be called as sensitivity of that gyro sensor. So output would be, let's say, a voltage in millivolts or volts divided by an input. Input is what you are measuring, the rate of movement in an angular way. So that's the degree of rotation. So it is called as degree per second. Okay, so that is your degree per second. That's your input, and the output will be, let's say, millivolt. So ratio of this will give you the sensitivity of this device. Now coming back to our discussion, this is your breakout board. So let's inspect one by one all the components of this board. So I said in the beginning of this video, it is inertia measurement unit, because this board contains an accelerometer and a gyroscope and a magnetic field sensor all together. So that's why it is called as inertia measurement unit. So the first two sensors, they are inertia sensors, accelerometer and gyroscopes, and in combination with that, you have been given a magnetic field sensor which can sense the magnetic field component in all three axes x, y, z. Similarly, acceleration sensor will sense a change in linear velocity in all three axes x, y, z, and the gyroscope will sense a change in angular velocity in all three axes x, y, z. So total 3 axes for each sensor. So 3 multiplied by 3 is 9. That's why it is called as 9 degree of freedom, IMU. So inertia measurement unit. Now all these sensors have been put up in this small integrated circuit package, all these three sensors, and let us have a look at this portion of the PCB. So what you see here in a small letter, there is a printing of ACCEL, that is an accelerometer. Then beneath it you have GYRO, that is a gyroscope, and MAG stands for magnetic field. Okay, and there is also X, Y, and Z written over here. So first of all, we'll see that there is a small arrow here, straight arrow pointing in this direction. So that is your direction X, positive X, and backward would be negative X. Then just next to it there is an arrow pointing in this direction, and back to it we will indicate it's a positive and negative y-axis movement. And then there is next to it is a small circle, and there is a small dot within it that indicates out of plane. So it means, let's say this PCB board, I hold it in my hand and I move it in the x direction shown right here. Take a look at this, up and down. So I am moving it in a positive x and negative x. Then I hold the same PC board in my hand and I move it in the y direction as shown. So to the left and the right. So that is the y-axis movement. And I hold the same PC board in my hand, and as shown by the out of plane or Z axis, I take it outside this plane, that is outside this screen, and then put it back inside the screen while I am recording this video. So that's your Z axis. So all three axes have been covered. Now, so that's your acceleration sensor. This is how your acceleration sensor will work. Now let's see how the gyroscope will work. For example, there is an arrow for the x plane or x axis indicated in this way. So it means I put this portion of the PCB down and I take this portion of the PCB up and rotate it, I tilt it. So that is your first axis or in the first plane. Then you have y indicated by this curved arrow. You see here there is a small arrow here. Okay, let me use the different color for the proper indication. For example, you see there is an arrow here with the tilting as shown over here. So let us draw that arrow again. It is right here, and it means I this portion of the PCB I press it down, so this portion of the PCB, this side of the PCB will come up. So there is a bending or tilt of this PC board, and there is an angle. That angle will be detected by your gyroscope. So we have seen X, press it down and this part will go up. Then we have seen Y, press this down and this part will go up. What about the Z? So Z angle or rotation has been shown by this kind of curved arrow, you can see now. So it means I am bringing this part here, this side here, this side here, and this side here. So I'm just moving in a circular way in the same plane, this PCB. So that rotation or that angle will be captured or recorded or measured by the gyroscope sensor. So you see, in all three axes I got the gyroscope sensor working. Now the final part, you have this magnetometer or magnetic field sensor. So the arrow showing this direction will measure the magnetic field component in X direction. Arrow showing in this direction, look at this side here, will measure the magnetic field component in the Y direction. And then there is a cross circle like this, will detect the magnetic field component in the environment in the Z plane or the out of plane direction. So we have covered how this IMU 9 degree of freedom sensor unit will work and give us different physical quantity measurement. What is this IC? That is your microprocessor mu P. So this microprocessor is there to take the data from this inertia measurement sensor units and process it, and then through the communication pins, for example SDA, SCL, they are for external interface. You can connect it through the computer or you can connect it to your data acquisition unit and so many other things. This is your capacitor right here, these are your capacitors again, and these are your resistor. This one, these three are the resistors right here. Again, this is your capacitor, these are capacitor right here. This is your crystal, this is your crystal, and that's it. So you see now there are various pins and breakout board is there. These are the through hole connector components that you can connect your. This is your ground pin. 3V3 is your power supply, that is a 3.3 volt that this breakout board will need. This is an input to the board, and other pins you can refer from the data sheet of this. So hope you understand what this IMU means. We also explained what is an inertial sensor. We started with that definition. We covered what is a Newton's law in a basic sense, and now moving on to this second part of the breakout board, you see it is a 6 degree of freedom, 6 degree of freedom IMU unit or IMU simply. So here you don't have a processor, you just have this IMU IC in which you have only two sensors. One is an accelerometer and one is your gyroscope, and that is why you call it 6 degree of freedom, because 3 axes will be covered by an accelerometer, linear axis, and your angular movements will be covered by your gyroscope, another 3 axes. So 3 plus 6 makes 6. Magnetic field sensor is missing from this breakout board, but the rest of the connections are same. You can simply type this number, this one, like for example SMD SM6DO SM6OS3 on the Google and refer to the datasheet. Again, if you notice carefully this section, you have straight arrows X, Y, and the Z is indicated by the circle here to indicate the linear movements in XYZ, and then you have arrows like this, and arrows like this to indicate the three tilt movements in XYZ plane. So that is about your 9 degree of freedom IMU and 6 degree of freedom IMU. So hope you like this video, because we've covered all physics involved in the physical principle of these devices and sensors, and then I introduce to you the breakout board, the various components of it. Some other pins on the breakout board can be understood by referring to the data sheets. Just type the number of this unit. For example, this is from the spark fan, and you just type this information on the Google: spark fan 9 degree of freedom resor IMU, and you will have access to the data sheet from the manufacturer. So we covered the physics, we covered the basic principle, we understood the very good way what is the inertia sensor, what are its types, what are its applications, and how they work, and all those three kind of sensors. So hope you like this video. If you did so, do share with others, spread the knowledge. We are transferring the knowledge. Like and subscribe to the channel. Wish you happy learning.